Welcome to our channel. Let's begin the journey.
Today, we're going to completely bypass the usual preamble and drop right into what is honestly one of the most cinematically dramatic and deeply tragic stories in the entire history of theoretical physics. We're talking about a moment where the absolute pinnacle of human intellect literally collided with the worst of human destruction.
So let's just jump straight into this absolutely wild contrast. Picture this. On one hand, you have the horrific, visceral chaos of a world at war. We're talking the filthy, muddy, violently artillery-battered trenches of the World War I Russian front. And directly against that, you have the silent, absolute perfection of mathematical physics. Albert Einstein's incredibly beautiful but overwhelmingly complex theory of general relativity. It is almost impossible to imagine these two completely totally different worlds ever overlapping, let alone interacting in such a profound way.
I mean, the sheer weight of what Einstein had just created was staggering. His new theory was undeniably a masterpiece of human intellect, unifying space and time into a single fabric. But the equations were so terrifyingly complex that even Einstein himself genuinely believed it would take a very long time before anyone could ever find an exact mathematical solution to them. He really thought he'd laid out a puzzle that was going to baffle the brightest minds in the quietest, most pristine university libraries for decades.
But shockingly, it didn't take decades. The scientific world was absolutely stunned when that elusive solution was found just a few short months later. And the craziest part? It was discovered in the most unlikely, chaotic, and dangerous place imaginable.
Section 1. Genius in the Trenches, Finding Mathematical Truth Under Fire.
Enter Karl Schwarzschild. He was a highly dedicated German physicist and astronomer with just superhuman focus. In 1916, he wasn't sitting safely in some state-of-the-art modern laboratory. No, he was actively serving his country on the Russian front. Just imagine this scene for a second. Right between deafening artillery barrages, amidst all the mud and the terror, Schwarzschild managed to write a brief but absolutely monumental scientific paper. He was elegantly decoding the deepest secrets of reality, while literally trying to survive incoming artillery fire. It's mind-blowing. So what exactly was he calculating out there in the filth?
Section 2. The curvature of space-time, defining the shape of reality.
Yeah, possessing supreme mathematical skill, Schwarzschild basically did what Einstein thought might take a lifetime. He derived a precise, beautiful mathematical solution. He managed to perfectly map how massive objects warp the physical fabric of reality. Specifically, he mathematically described the exact curvature of spacetime existing around a non-rotating spherical mass. He calculated those exact physical dents that Einstein had originally theorized, proving the mechanics of gravity with absolute mathematical rigor. But as we really get into this explainer, we find that his beautiful mathematical solution also clearly pointed to something else, a highly extreme, almost terrifying consequence.
Section 3. The Schwarzschild radius, a dark mathematical consequence.
You see, Schwarzschild's math showed what happens if you take things to the absolute extreme. Think about it like this. Step 1. Imagine you compress the entire mass of a celestial body into a tiny physical radius. Step 2. The surrounding spacetime naturally bends, but because of that immense density, it bends drastically. Step 3. The math dictates this violent cascade where the fabric of spacetime completely and inescapably closes in on itself. And finally, Step 4. The required escape velocity just to leave that localized pocket of space becomes vastly greater than the speed of light itself, and since nothing can travel faster than light, nothing can ever leave.
This brilliantly illustrates the exact point of no return. We call it the Schwarzschild radius, that specific, invisible boundary in space around a highly compressed mass. Once you cross this perimeter, you are gone from the observable universe. This concept, drafted on a soldier's dirty scratch pad, is the absolute, concrete mathematical boundary of what humanity now knows as a black hole. And suddenly, these were no longer just abstract numbers.
Section 4. Cosmic Monsters on Paper, Predicting the Unseeable. And this is why this matters so much to our understanding of the universe. Schwarzschild definitively proved that human mathematics, theoretical physics, possesses the amazing power to accurately predict extreme cosmic phenomena. By mapping out this terrifying anomaly where light gets swallowed entirely, he effectively predicted these terrifying monsters lurking deep in the cosmos decades before human instruments, telescopes, or satellites could ever hope to actually see them. He literally found the invisible using only his mind. Yet the story of this monumental discovery is ultimately one of heartbreaking timing and tragic irony.
Section 5. A tragic legacy, the heavy cost of discovery.
The sequence of events here is just devastating. In 1915, Einstein publishes his incredibly complex general relativity. The very next year, 1916, Schwarzschild mathematically solves those exact equations amidst World War I artillery fire. But then, tragically, in that exact same year, Schwarzschild contracted a severe illness at the military front and died very shortly after completing this groundbreaking work. Decades later, his brilliant math officially became the concrete foundation for our modern understanding of black holes, but he died never getting the chance to witness his mathematical vision change the entire landscape of astrophysics.
So to wrap up our explainer today, I want to leave you with this final lingering thought based on Karl Schwarzschild's permanent legacy. If a soldier in a muddy trench could use theoretical physics to predict terrifying, light-swallowing monsters decades before we had the technology to actually see them, what other incredible, bizarre, or even terrifying monsters are currently hiding undiscovered in our mathematical equations right now, just waiting for the right genius to find them? Thanks for joining me. Keep questioning the universe around you.
The view from here is breathtaking. Command, we are in position and ready for the next phase. If you liked the video, subscribe and comment the topic you want next. Thanks for watching, and stay unstoppable.